This method demonstrates a fabrication strategy for creating sophisticated, biocompatible hydrogel-based microdevices, which are incorporated with moving components which can be magnetically actuated. The main advantage of this technique is that it is a rapid and simple method for microfabricating complex devices out of PEG-based hydrogels, which are FDA approved for use in humans. This results in an entirely biocompatible and implantable device.
To begin, review the accompanying text protocol and use it to fabricate the PDMS chamber and design the photomasks as described in the accompanying text protocol. Next, create the top lid for the PDMS chamber using an untreated piece of a No. 2 glass cover slip. Starting from the 0 level of the device, lower the bottom substrate using the micrometer head to the desired height. Deposit a small volume of the PEG-DA prepolymer sufficient to cover the bottom substrate and then place the top substrate onto the PDMS chamber.
It is important to ensure that there are no air bubbles trapped between the top and bottom substrates. Air bubbles will result in large pores or defects forming in the polymerized hydrogel.
Next, place a photomask with the desired design on top of the top substrate. Ensure that the mask is in full contact with the top substrate and aligned to the substrate's bottom. Place on protective UV goggles. Then expose the hydrogel prepolymer to UV light through the photomask. The power and duration of the UV exposure depends on the type of system and PEG-DA formulation. After the hydrogel layer has been